Okay, welcome everybody. Firstly, my name is Latko and I'll be your host for the rest of the day. For those who came for Dražen and Stefan's panel, it's gonna happen in a room next door called Mosaic at 4:15. For the rest of you, hopefully you had amazing lunch, but also hopefully you still have some space left to eat up knowledge from our speakers. Our first speaker for today is Catalin Gheorghiu, hopefully I said it right, who's a solution architect for EPAM systems. He's going to discuss, his subject is processing custom vision output. So Catalin, come to
So
the stage.
I have the stage and I have a lot of microphone. So hello, welcome to the first session after the lunch. Yeah, I'm Catalin Gheorghiu. I'm solution architect at EPAM. We also have EPAM in Zagreb. So yeah, we're not going to talk about our customers or what we are doing, but we're doing a lot of interesting stuff. Moving on. Okay, it's nothing important, but well, let's try to do again duplicate. Yeah, that's all. So from the year 2011, Microsoft awarded me each year the title of Most Valuable Professional. My categories are Azure, Windows Development, and IoT. Pretty rare. And also I'm Intel Software Innovator and Microsoft Certified Trainer. So pretty much this is about me. We can do this session to be even interactive and even sweet. It's your pick. So let's move the slides. We have a very interesting slide. I got your attention. So let's get rid of the slides and move to the to this. Let's first understand what are the terms for custom vision. So what we have. This is a website. We're gonna. It's nice because it has the nice picture. So we have classification. This means that we see in a picture in a stream that it's Ellen. We do not know where it is. Then we have localization. We have a square. Here is Ellen. Wonderfully. Detection. When you have more than one, we see whoever it's here. I don't know them all. Hey, Ellen, whatever. And segmentation, it's, when you know exactly where they are. Let's say the most common are the first three ones that we're going to see. Detection and localization. Let's try to be interactive. I'm going to show you something. I'm going to ask you, what's that? Any ideas? Okay, so let me dig into my, because you are very curious. And yeah, it's a JSON, but what kind of JSON? This is the output of a real. In fact, okay, it's a real hardware, but usually what you get from a custom vision solution, this is it. So you have in the bounding box. Let's getting back to this. So you have this bounding box, the coordinates, and you have what more? The label, what it is, the confidence, and the timestamp. What is the confidence, in your opinion? Again, I can talk. I have half an hour. It's no problem, but I want to get rid of the chocolate. Yeah, and that's, sorry. Look, in artificial intelligence and custom vision, we are not talking about certainties. It's not certain. It's not that in that picture it's Catalin or Ellen. It's something like 80% or 20% that it's Catalin or Ellen or somebody else. And here is the percent as something like this. This is real, from a real hardware. This is how it looks. You'll have the bounding box, you have the label, you have the confidence. Okay, let's get to the site. Let's try to see the depth of the problem that we have. So, up there, they show from the live video getting images. You see the bounding boxes. the colors are conventional. They do not care. They just put different colors. Let's say the last time I was in this building, we had a demo with real hardware, and they were detecting people and detecting cravats, neckties, cravats in Croatia. So it was, yeah. It was nice, but you kind of start to see the problem. So, and now we'll do the, let's say, the 1950 TVs. So I will try to draw something, and we'll discuss it. We'll do sing and dance. Let's see if we are still connected. We'll get it back active, just a second. And what's the problem with this? Present with screen share. Okay, connect, got it.
How do you guess the probability of that what you don't know?
Okay, just a second to restart this off screen. Could you please repeat the question?
How do you know your starting probabilities of an object?
No, this is generated from the camera when it's doing inference. So this time does not work that nice, but okay, I'll restart this application. Nevertheless, so what are the problems that we can see as now? Yeah, this is the wonderful part, but we'll let it die. And hope yet again. And if it does not work, I will try to work my magic otherwise. Okay, we'll do it without it. And the demo gods are against us. First, you see the images. They are dancing. Okay, what we want to do? For example, we want to get the number of all the vehicles on this live stream. You see it's a problem because first the bounding boxes move, and second they are not in the same frame. So let's start filtering the issue. As I said, the target is to number all the vehicles. First will be to push out the one that have low probabilities. So we must set up a threshold. And that will be the first step. This is pretty simple. We can do it even in simple SQL. Looking back to this, we just say that we want confidence to be bigger than, let's say, 0.9, 0.8 or something, and we want to have the right label. Okay, this we did the first step. But again, getting back to the picture, we are continuing to having problems. Because you see in one frame, if you take one frame, sometimes the images are not, the bounding boxes are not there. And this is happening in the real life. To get an idea, all this is usually done by hardware. So you are, in fact, if you are following the Microsoft world, in the Microsoft world, to do this kind of solution is just click, click, and click. You are getting the picture, moving the picture to custom vision, and then you deploy it on some hardware. And the hardware, just again by click, it's giving you the bounding boxes and that output that you see there. So all the inference is done in hardware. There are two big players in the field. One is Intel, and with the Movidius chip. I'm from Timișoara. You can guess on which town was the company which was bought by Intel founded. Yeah, it's a let's say a Romanian success story. There was a chip manufacturer, Movidius. It's really the initials of the man who created the chip, and now it's bought by Intel. what is the use that you have seen? If you've seen the World Cup at football, there was some drones that were following footballers on, and that were using the Movidius chip. Okay, similar. NVIDIA, it's very big on the market. So they are getting with new chips to do inference. What's the biggest difference between them? Movidius works with 1 to 2 cameras. NVIDIA chips works with 20, 40. You can connect and get this live stream and start doing bounding boxes and running your model on top of that. Okay, so first, we filter by label and confidence. Second, we need to somehow see what's happened, because if you see here, sometimes this bounding box, it's blinking. You have it in one frame, the next frame you do not have it. So what should we do with that? Because we want to number the number of cars in this frame. One of the ideas is not to use only one frame. Try to use a time period. And in that time period, we want to number all the bounding boxes to make this kind of average. Let's try yet again to connect with that stupid thing. And if we are able, because now we are continuing the discussion to the topic, how do we know that the square, for example, if you know the red square, this is moving a bit, and also changing a bit the dimension. How we know it's the same? Because now, okay, we filter the probabilities. We filter other labels, but now we have squares that move a bit, and sometimes are there and sometimes are not. They are changing the dimension and changing their positions. So let's try to do this. And we'll try again with wonderful screen share if it's, because this will help to me to draw a bit. If not, it was just a gimmick that this time did not work. Okay, we do not care about update error. Of course, I'm not connected to the internet, that's the problem. No, I have my hotspot. So, yeah, now it's working. So, screen share is connecting. So now you see, these are our 4 squares at the beginning, but they move. So for example, for this move over this one. And then we try, this one will get a bit smaller. And this one afterwards will be nothing at all. Let's say this is a second 0, second 1, and second 2. And we're still no, because we as people know that we are 3, but the solution must know that there are 3. So what are the first ideas? First, we are doing an average on this. So we're numbering the max number. This we talk already. Second, it's how do we know that this square, even if it moves a bit, let's try to do another page. For example, yes, this square has moved a bit and it's a bit smaller. How do we know it's the same? One of the idea would be to get an, let's say, a circle at plus minus 20% of the corners, and try to analyze this. If we take in our interval of time, if a square has his corner in approximately the same areas, plus minus 20% of plus minus 5%, it's the same. That's one approach. It's not nice. Again, it's doable, like everything I'm going to show you in this session, is doable by just simple SQL. Okay. The next approach will be, how about the area? Because usually, if we look here, again, have a question? Okay, if you don't have a question, let's get back. If you look here, the area of the squares is pretty much constant, because yeah, the camera doesn't move that much. So we can assume that the area of the square is pretty much stable, plus minus 20%. Or something. This knowing your data, I would say in the application that we have developed, it was from 5% to 20%. And we got reliability up to 99.9, sorry, on this. But again, let's say that we are not satisfied with this. So we put also the area. If the area is plus minus something, 5 to 20%. Other idea would be to recognize, because this will be how to recognize, how to see that our squares are the same. This is the presentation all about. And let me get back to this screen share. So we get the area. Other idea would be, let's say, again, try to make it nice. We have our squares in this manner somehow. And yes, if you ask, always would be squares, because this is how the custom vision works now. Besides segmentation, which will show exactly the face or exactly the person, everything else works by squares. Again, what I'm trying to give you with this presentation is to tell you that custom vision is something on the plateau of productivity. You do not need to be a data scientist. You do not need to be afraid. You can try it even now, and even I'll say Microsoft tools, you can run the models, you can trade them, you can test them without opening any hardware. So you've got to get to customvision.ai and put your pictures, label it, and train the model and get it back. So it's on the plateau of productivity, something that you can start using today. Getting back to this. Another idea would be to get the center of the squares, and see if the center is still in the same area, plus minus 5 to 20%. But if we are looking back on the example that we have, you will see that the centers are not moving that much. Even the error, the corner will move a lot more. The center will remain very stable. So that will be another indication to show us that we are talking about the same thing. Okay, yeah. You are doing now the karaoke.
Probably I missed the first 5 minutes. So if you have this data, you have something like a sampling every second of the moving.
No,
images.
you get it, I would say, data how you receive it. All the hardware that we work with,
yes,
looking like this.
Yes.
So you are getting this stream of data, and here you have the timestamp.
And then you have, after a second, you have the
no,
same data.
when they have new data, when they have inferred something new. This
but
is
how do you know which steel ball, how do you recognize this steel ball in the next second?
But that's exactly what I'm trying to...
But why don't you do something like the color doesn't change? So you measure measure of the color in this area.
Okay, that's an interesting topic.
And the conditions that they are not sampled 1 hour. So if you have
yeah,
you almost...
that with the color, it's a very interesting subject that we... the color is very dependent on the camera. So one of the first things that we're doing with the camera input is to do it black and white. Because I'll give you a real-world example. Again, the Romanians are not that good at mathematics, but are very powerful. A real-world application. A Romanian worker need to put 5 screws of the right kind on something. And the solution, they discovered that either they are too powerful, they put the wrong kind of screws, or too little, or something else. So they come to us to engineer a solution to do this. And what was the solution? First, the normal solution is to put a weight counter. So you see, the screws, the right kind of screws have this weight. But the problem is to get a difference between screws are in the, let's say, 4th decimal. And these take time because, it's a hardware approximation. It's going round, round, round. And thus, it's not absolutely precise. So we put a camera on top, and we train the model. Everything worked fine until, again, the Romanians are not good in respecting processes. So some of the screws are blued. So they had a different color, and the model got this as was a huge difference, even though they were the right screws. So, and this does not go only with the screws. Use filters, because the colors, the models, custom vision models have an affinity for colors. And sometimes the camera and the lighting are very, very important. For example, if you take pictures at the beginning of the day and you are trying during the day, you'll get different results. So the rule of the thumb, it's always... yeah, but it takes a lot, and it costs a lot. Another solution that we make, it's again very interesting for Croatia. It's an insect trap. So not to spray crops when you do not need it. There is a special something that catch the insects, recognize them, and send to the farmer. Look, you need to spray for this. And yes, it's laughable, but it's a huge market. Again, first off, we apply a filter because we want it to be black and white. And okay, sometimes we put also a sound model we have on top of it, but that was too expensive. Usually we use just a custom vision model before the insect is killed, because by European regulation, you need to kill the insect. You cannot let it back. You capture it with pheromones, you identify it, and you kill it, and also you keep it for retraining the model. So, yeah. On this, unfortunately, my recommendation is always use a filter, because then you're getting to, usually starting from black and white, it's the best to avoid this. And getting back to what we have talked before, it's no longer active. What I like about it. So stop sharing, try to share again. Nevertheless, accept. Now, because we're on the net. So we have talked first about the corners, second about the surface, and third about the center. This is how we can see that we are on the same square. For best results, of course, you need to combine them. Again, bear in mind this is not complex. It's again a task that any procedural programmer or SQL programmer can do it. To do a calculus in a row of data, of getting all this together. And applying this, you're getting very good precision on top of it. So let's try a recap. The problem is that we are getting the data, how it comes from the chip. The chip decides at his moment and his whatever will send the data. We won't have all the squares in all the data he sends, because sometimes does not feel like it. It's, you see how it flickers. This is the technology of today. So you see the flickering. And this is not because the camera is moving, because this is how the inference is going. So first, we need to filter the labels that are not interested with and get our confidence right. Because if you put confidence at 20%, you'll be swapping data. You put it the right confidence. And then try to see which are individual squares. And for this, I'll show you a couple of techniques of doing it. Again, everything is at the grasp of your knowledge. Everybody in this room can do it. All this solution, all these calculations. And you'll see the custom vision is not complicated. You can do it even for stupidest thing in the world, like potted plants to see if they need watering, like everything. And they are not expensive. Again, getting back to my knowledge in Microsoft, 2 custom vision models are for free. Okay, if you want to deploy it for something, you need something. Also, the training, it's free if it's reasonable. So if you train a very huge model and will take something like 10 hours, then it will be an issue. You need to pay, but something like 400 pictures will be, again, reasonable as it goes. What else I need to tell you? Generally, the inference is done by hardware. So you do not need to do it by software. And if you do it by software, it's emulation. There are two big providers in the field, Intel and NVIDIA. Now all the bets are in NVIDIA, and will be a lot of interesting solution up there. So again, it's not something that you maybe want to hear. It's a very democratic solution. You can use it even now. Again, usually you do not need a lot of programming knowledge or data science knowledge to access this. I would say that Intel, unfortunately, has a bigger entry level because the OpenVINO platform that they use for our hardware. Okay, what's that? That's an abstraction layer to the older hardware platforms in the custom vision field. It means processors, graphic boards, Movidius chip, and all the rest. That generic platform, it's, let's say, the guy who designed it was a huge fan of Bugs Bunny, Dushka Dgoushka. So it's a Rube Goldberg machine. It's so, until you make your DLL to be able to call the platform, you are, let's say, pretty. But when you have done your first DLL, then you are smooth sailing. But the first DLL to do it, you need to do new C++ and stuff, and to understand how from 20 projects, 20 empty projects, you create a DLL. And okay, has a lot of advantages when you get it running, because optimize also the model internally, optimize the weights to the processor, and a lot of stuff. But until you get there, you're screwed. Also, on NVIDIA side, I would say I heard all the buzz. And we are nearing a bit the end. We have something like 3 minutes, and now it's your chance to do the karaoke. Who wants to sing something? We'll have only the microphone. But yeah, but you have the microphone. If you do not sing, you can ask a question. You get the chocolate.
Which city to the east from Budapest was the first city where the tram drawn by horses was introduced? And
Okay, I won't participate.
But, no, you won't.
Yeah.
So, because I want to get rid of this, guess in which city the first tram east from Budapest through. No?
I would say, yeah, it has a connection with Movidius yet again.
So probably somebody. No.
No, it's in Romania. It's the city I'm from.
So probably then I have to give you back the chocolate.
I know.
So why I was thinking, because probably that's why they invented the software to detect, because they had competitive advantage, because the Temesvar saw the first moving cars, so you could do this.
To round up, that was a successful story from academia, but unfortunately not from Romanian academia. The Movidius chip and the guy behind it started working this in foreign, I believe in Germany someplace at the school. And they started the company and incorporated in England and moved so on and so forth. But Intel jumped to the conclusion. And Movidius, it's now like a stick. I do not have one with me. You can put it to everything from Raspberry Pi to PC, and it works. Again, OpenVINO, unfortunately.